Lecture 9, linear momentum. The first topic is about the moving control volume. And this figure shows the water jet from nozzle. This is nozzle with the velocity v1 is to strike the vane. Push the vane moving with the velocity v0. This is v0. We want to know how much force to drive the vane for designing a water turbine. In this case, it's more convenient to analyze by using the moving control volume. So this control volume is moving. This is we assume that this control volume is moving. The size and the shape of the control volume does not change with time, moving with a constant velocity vcv. That is the velocity of the control volume. Velocity of cv and water particle are not equal. Okay, that is the velocity of the velocity. Okay, not equal. The difference between the fixed control volume and moving control volume is the relative velocity W, or ความเร็วสัมพัทธ์ of water flowing through the moving control volume, whereas the absolute velocity is water velocity flowing through the fixed control volume. This figure shows the typical moving control volume and the system. You can see that the moving control volume from the black line to the green line, and for the yellow line is the system as time t1. Okay, so we can write equation that the velocity of control volume is equal to absolute velocity subtract relative velocity, or absolute velocity equal to the absolute relative velocity plus the velocity of the control volume. So W is the flow velocity observed by the observed on control volume, and V is the flow velocity saw by the observer on a fixed coordinate, and VCV is the velocity of the control volume as seen from the fixed coordinate system. So I compare to this one, if we, in this case, if we assume the control volume as an airplane is moving with the velocity of the 100 meters per second, and one person is running in the airplane with the velocity of the 2 meters per second in the airplane. So W is mean the velocity observed by the observer in the plane and airplane. So if for the people sit on the ground, we can see that the absolute velocity of the people is equal to W plus the VCV is 102 meters. Okay, that is a combination of the vector between the velocity of the control volume and relative velocity and absolute velocity. So from the transport theorem, we can replace the velocity v with the relative velocity w in this w time dot n. And then for the conservation of mass for the moving non-deformed control volume, we can prove that this is equal, the change of the mass inside the control volume equal to 0, and the change of mass on the surface on the control surface is 0. Next topic is the selection of the control volume. A volume in space can be selected to be the control volume. Selection appropriate CV is the same as the selection of the free body diagram in the static and dynamics. So selection CV is no wrong, but which one is the better and the best CV? Okay, so we want to find the solution for parameter velocity, pressure, force acting on the point in the flow field. Therefore, this point should be inside the control volume. Okay, control volume is the select to allow this point on the control surface. Okay, for example, you want to know what is the force acting on this point 1, so we have to draw the control. This is that line is a control volume passing the point 1. Okay, and the location of the control surface is should be perpendicular to the velocity. Okay, that is the should be perpendicular to the velocity for the control surface. Then because of we get the theta is 0 or 180 for dot product, which is easy to get the solution. So that is the good choice, but this is not a good choice because it's not velocity is not perpendicular to the point 1. See that point 1 is, so this is not, short B is not a good choice.